Hello, I am Mr. Rogers, and welcome to our next video lecture here. Today we are on section 2-2 in our book, and really today is covering the periodic table of elements. So in the last lecture we talked about atoms, and now we're putting these atoms, which there are over 100 known different types of atoms. We call those elements, and what scientists have done is place these elements into the periodic table of elements. And so today it's all about reading and interpreting the periodic table of elements. So in front of you on your screen, you can see here are all the known elements so far. There's a few new ones being discovered down over here, but by and large, these are the elements that are found here on Earth, anyways. You can find on Earth, and some you've heard of before, I'm sure: hydrogen, carbon, oxygen. Some are more weird. You may have never heard of before. Yttrium, maybe one probably never heard of that one before. But these are all different types of elements. So each one of these boxes represents a type of atom and how that atom is composed. And so what we're going to do first is kind of break this down. How do we read these individual boxes that are in the periodic table? Now, if you're actually listening to this, please listen. Don't just write. Obviously, once you write down the box you see here, and different symbols, and label what you see in red: the atomic number, the atomic mass, the name, and the symbol. But don't worry about the symbol's definition, where it's derived from. Also here for the atomic mass, you can see a lot of times these are not a whole number, because it tends to be the average. We're talking about the average of all the isotopes. And so on average, carbon has an atomic mass of 12. It can be higher than that. So, and what is the atomic number? What I really want you to write down for atomic mass of an atom is that it is made of the sum, adding, number of protons and neutrons added together. And so we have those protons and neutrons there in the nucleus. That gives us our atomic mass. And that's what you have to write down. So if you're not listening, you'll probably write down way too much. So here's how we read the individual boxes inside the periodic table. Carbon, the atomic number is always up top, and again, number of protons in the nucleus. The atomic mass is below. Sometimes they'll have the outer shell number over here, but typically the basic ones have these things in them. So we put these boxes, and they're arranged in a pretty specific order. They're not random. They're there in their places for a reason. A couple of facts here about the periodic table is that atoms are arranged on the periodic table by their atomic number. So that number on the top, that number of protons in the nucleus, that's a very important number. If an atom is neutral, that means equal number of protons and neutrons, protons and electrons. There, third time's the charm on that one. That means it's neutral. So if you have 10 protons, the atom's also going to have 10 electrons if it's neutral. But it's arranged primarily by that atomic number, which is that number of protons. Secondly, each element or atom is listed on the table by two things: their atomic number and their symbol. That's really what you can see. Primarily, what worry about is the atomic number and their symbol. Thirdly third thing, an element's properties can be predicted from its location on the periodic table. And we'll spend more time on this in the future here, but that's a big deal. Where it is on the periodic table tells a lot about the properties that the element is going to have, just based on where it's located. So it's kind of three big facts about it. And as far as how it's arranged, the periodic table is arranged into groups or families. And these are a group, or all the elements in the same column, the same vertical up and down column, would be in the same family. So if we go look at our periodic table, and we'll come over here to the yellow, you can see over here all the elements in this column, this up and down column, have similar properties. These elements are known as the noble gases, which means they do not react with really anything because their electron shell is filled up. We'll talk more about that later on. But that's the idea of a group or a family. All these columns, the up and down columns, are in the same group, so they have similar properties. So, and there are 18 different groups or families in the periodic table, coming from 1 all the way over to 18. 18 was actually that group I just showed you. So typically, each group is given a family name based on the first element in that column. So look at that top element, and that's typically the name of the group. And then finally, another way of organizing there is the rows that go horizontal are known as different periods in the periodic table of elements. And also, we divide kind of three basic groups or types of elements on the periodic table. The first one are metals. And metals are generally found on the left side of the table. So all the elements on the left side are metals. And we can go take a look, and you can stop if you got to take notes there. But all these elements, you can kind of, anything from this zinc over here, these are all different types of metals. Some you've heard of before. You've heard of iron. You've heard of gold, silver, copper. Again, these are all different types of metals. Again, this left-hand side is filled with them, different types of metals. So, from there, whoops, wrong one, we have our nonmetals. And nonmetals are generally found on the right-hand side of the table. So, let's take a look at those. So your metals, your nonmetals, are going to be, especially here over in orange and yellow, are going to be things that are nonmetals. So oxygen, we breathe it in, not a metal. Neon gas, not a metal. Helium, not a metal. The one exception that is over here is hydrogen. You can see it's in its own color. Hydrogen, even though it is on this left-hand side, it's a non-metal. Hydrogen is not a metal. But again, chlorine gas, those are all non-metals. And then our final group are called metalloids. Metalloids. And so a metalloid, they kind of follow that zigzag line between metals and nonmetals, and they tend to have some properties of metals and some properties of nonmetals. So these elements, kind of this zigzag line that kind of goes down here, elements on either side of this line tend to sometimes have properties that kind of go with a metal or a nonmetal, depending where they are. So they're kind of called the metalloids. They're kind of metal-like in some cases. In some ways, they're not.